solutions are homogeneous mixtures. What does that mean, homogeneous? The same throughout, right? Heterogeneous means it's not the same. Homogeneous means, see, y'all learned something early on in the semester. Way to go. See? That'd be a good question. What does homogeneous mean? Okay? How do you form a solution? Well, there has to be enough attraction between the solute and the solvent, two new terms. Okay? So the solute has to be attracted to the solvent. The solvent is the thing that's there in a much greater amount than the solute is. Okay? So their example over here is they are dumping some salt into water. Who's the solvent? Who's the solvent in that example right there in that picture?
Water.
The water is the solvent, and the salt would be the solute. The salt dissolve in water. Anybody ever dissolve any salt in water?
Yeah.
When you cook, right?
We could just pour it in the salt with it.
Yeah, but it all dissolves eventually. Okay? Might take a couple of minutes or something for it to dissolve, but it will all dissolve. Okay? So, why does salt dissolve is a good question. Because there's an attraction between the salt, the atoms in the salt, the ions, and the water molecules. We're going to talk about that, how this works. So, solutes might be gases, liquids, or solids. They spread evenly throughout the solvent, and they mix with the solvent. They cannot be separated by filtration, but they can be separated by evaporation. They're not visible. You can't see them. Anybody remember that we talked about Gandhi in here? Remember us talking about Gandhi? What did Gandhi do? One of the things he did. They went down to the ocean and they evaporated seawater. Why did they evaporate seawater?
To get the salt.
To get the salt. Where did the salt come from?
The salt water.
The salt water. So who was the solvent?
The salt.
The solvent was the water,
How does it evaporate?
and the solute was the salt. There's more water than there is salt, right? And the only way to collect that solute is to evaporate the solvent, the water. Okay? Could you see the salt in the water? When you go to the beach, can you see the salt in the water?
No.
No.
You can feel it whenever you get out, though.
Why do you feel it when you get out?
So it sticks to your skin.
Why? How's that work? What's happening? The water's evaporating, right? The solvent evaporates and you're left with the solute on your skin. If you lick your skin, it tastes salty, right? You got your dog with you, they come up and lick you because they like the salt? Huh?
I feel like you've said that.
Now here's the solution. You can see it. Now look, this is copper sulfate. If you haven't seen it in lab, you will see it. It's a blue solution. You cannot see each individual ion, but you can see the fact that the solution is blue. The copper turned the solution blue. So you don't see each individual ion, but you see the impact of it. The only way to collect the copper sulfate back out of that water would be to evaporate the water off, and you would have the copper sulfate left at the bottom. Okay?
Why is the copper turned blue instead of a rust color?
Because it's copper instead of iron. It's copper 2 instead of just elemental copper.
Okay.
Copper 2 is the blue color.
Because I mean,
Depends upon which element you have,
all right.
right?
Yeah.
They absorb different wavelengths of light.
Okay.
How's that?
Good. You said to ask why.
You told us to ask why.
That's a good question. I was shocked. I mean, still a little bit, might not make it now. So that's an excellent question. Now, you do not have to have a liquid to have a solution. You could have a solution as a gas. We skipped a chapter on gases. We're going to come back to it after we finish chapter 10. We'll come back to it. Okay? The air in this room is a solution. The solvent would be thought to be nitrogen because it's here in a greater amount than oxygen is, okay? We think a lot about liquids as being solutions, right? When you close your eyes and you think about a chemist, what do you think a chemist looks like?
Someone pouring
Beakers or test tubes or something in a lab,
Glass.
and he has liquid solutions, right? Okay, that's what you think of. Not all chemists do that. A lot, some of them do, but that's what you think, and that's a solution that he's working on. Okay, you can even have solid solutions. Okay, does there anybody here have an older edition of the book that doesn't have the firefly on the front? No, everybody has the firefly book. Okay, if you have an older book, it has a different solid solution. There are examples of solid solutions of brass and steel. There's another solid solution, and the dental hygienist in the room should know what it is. This is a test. Come on.
a solid solution.
A solid solution that you would use in dental hygiene. Well, actually, a hygienist probably doesn't use them very much, believe it or not. Hygienists, they clean teeth, they don't do this. The fillings are amalgams, right? They're a combination, it's a solid, right? It's not a liquid. And what's it made of? What's in the silver filling in your teeth? It's mercury and...
I don't know what the white stuff is now.
If there's silver, well, this white stuff is ceramic. But the silver-looking fillings, if you might have any silver-looking fillings, right? They're made of mercury and silver, and it turns it into a solid. They used to do gold ones too, which had gold and mercury in them, right? Turns into a solid.
I thought mercury was poisonous.
It is.
Okay.
But the amount of mercury that it releases is pretty low. Although there are, I had a friend, right? I used to do research, so I knew people all over the place. He developed an instrument for measuring mercury. And if you went up and you blew into his instrument, he could tell you pretty close to how many fillings you had. Isn't that kind of cool? He kept a little chart. So everybody would come up and do it. He would, get a number off of it, and then he would count how many fillings you had. And then he developed like a line, right? This many fillings means this value of how much mercury is in your breath.
So why did they use mercury instead of something non-toxic?
Because the amount of mercury comes out is really small. I mean, tiny, it's minuscule. It doesn't have any impact on your health.
Is that the same thing as the concept for the arsenic in the medicine to cure heartworms?
Yes. Yeah, you have to control that dosage just so it's just enough to kill the heartworm and not enough to kill the dog.
Okay.
Arsenic's also used to be used to treat syphilis as well. A lot of people died from it because they gave too much arsenic. Same thing. Yep. All right. Sidetrack. Okay. Why do things dissolve? Remember we talked about water? And it looks like this? Whoa. Back. Looks like that. If you go back to chapter 6, I think it is, you can learn about electronegativities. Which one has a greater electronegativity, oxygen or hydrogen? Oxygen is more electronegative than hydrogen, so oxygen will have a slight negative charge, and hydrogen will have a slight positive charge. Fair enough? Because oxygen is more electronegative. Kids spend more time with oxygen. Okay? So when you put sodium chloride into water, what do you think is going to happen? I'm going to have some sodium ions and some chloride ions. What do you think is going to happen? Is the sodium going to come over here and be by the hydrogen?
No.
Where's it going to go?
To oxygen.
Sodium's going to come to oxygen, and the chloride is going to come to the hydrogen.
Because the opposite.
Opposites attract. Now, this leads us to one of the great rules, and it's very scientific sounding. Like dissolves like. Do you hang out with people that are like you, that kind of believe the same stuff you believe? They like to do the same stuff you like to do, right? Well, in the chemistry world, that's